Right, verifying an identity. We love these. So let's look at this one. We always want to start on the more complicated side. I think that looks like the left side. And if you notice, you've got a quantity being squared. So what we'll want to do is basically foil that and kind of expand that out. So we'd have sine x plus 2 plus cosine x. I think I said plus 2, x over 2 times sine x over 2 plus cosine x over 2. We're just going to FOIL that out. So double distributive property, we're going to have sine squared x over 2 plus sine x over 2 cosine x over 2 plus another sine x over 2 cosine x over 2 and plus cosine squared x over 2. I see some like terms here and here, so I'm going to combine those together. I have sine squared x over 2 plus 2 sine x over 2 cosine x over 2 plus cosine squared x over 2. All right. So at this point, I've really got two different paths I can go by. I see a whole bunch of half-angle identities. I could use those. Probably the easier thing to do is if you recognize and see that there's a sine squared plus cosine squared in there. That's probably the easiest thing to do. So I'm going to show you the hard way first, and then I'm going to come back and show you the easier way. Let's say we didn't notice the sine squared plus cosine squared in there. We just see a whole bunch of half-angle identities. And so what I've got is a half-angle identity squared plus 2 times a half-angle identity times another half-angle identity plus a half-angle identity squared. And so you look at the sine, the half-angle sign, it says plus or minus square root 1 minus cosine x over 2. Okay? And so what's going to happen is you would need to know the quadrant normally because of the plus or minus thing, but because it's squared, it's always going to end up positive anyway. So that plus or minus is going to go away when it's squared. In fact, the square root is going to go away when I square it, just leaving me with 1 minus cosine x over 2 there. So then I've got 2 sine. Okay, wait a minute. I'm not going to use half-angle identities here. I've got 2 sine x over 2 times cosine x over 2, and that looks like the double angle sine formula. Okay, this is the double angle identity for sine, and so we're going to call that sine 2. Normally it would be 2a, but our angle here is x over 2. And so sine of 2 times x over 2, the 2's cancel, and I get sine x, so plus sine x. And then over on the right side, you've got the cosine half-angle identity. So that would be plus or minus square root cosine x plus 1 over 2. And again, like the other one, when that gets squared, okay, when that gets squared, the plus or minus square root goes away. And so we have plus cosine x plus 1 over 2 there. Okay. So a strategy that comes up every once in a while is splitting a fraction. So there when we have 1 minus cosine x all over 2, it helps to split that into 2 separate fractions. And likewise over here, it's going to help if you split this into 2 separate fractions. Don't really need to do anything with this sine x just yet, but we'd have 1/2 minus cosine x over 2 plus sine x plus cosine x over 2 plus 1/2. And what's going to happen, a couple things will happen. One thing you would notice is those things cancel each other out. And you'd also have a 1/2 plus a 1/2 is 1. You have 1/2 plus 1/2 is 1. And then this plus sine x comes down. You get 1 plus sine x. And if you notice, that's exactly what we wanted. Okay? We're trying to prove that the left side equals the right side. And that's what we did. That's what we got. And that's it. So now, I'm going to show you a different way. I'm going to show you maybe an easier way, I suppose. I don't know. We don't have to use those half-angle identities. So let's go back to where we were right about here. If you had noticed, this said sine squared x over 2 plus cosine squared x over 2. We know sine squared plus cosine squared equals 1. And so those two things together would equal 1. And then we still have this double angle identity. And that double angle identity is the double angle sine identity. We have sine 2 times x over 2, just like we did before. And those 2's cancel. I'm going to have 1 plus sine x right there. That was a lot quicker. Okay, that's a lot faster. Maybe you didn't recognize that, but that's exactly where we're trying to get to. 1 plus sine x equals 1 plus sine x. Left side equals right side. 2.